So we have a list of digits 0, 1, and we want to find if we can travel from the first position to the last position, and we only allowed to travel to zeros in some range, jump minimum to the maximum. This is jump. It can jump to this 0 and to this 0, and from that it can jump again to some this minimum and maximum somewhere here out of range. So the last target is in the range, so it can jump. So the solution is dynamic programming or line sweep. So my solution, my initial attempt was breadth first search, with trying to visit all the possible cells, and we only visit them once, but it still gave me time limited exceeded because some cases were made such that even if you visit them once, you still have to iterate all the children, and then we have n squared. So so the hint is use some like use sum. Okay, so imagine you have zeros and ones, and you mark, have a Ryan sum, and you have events. So I will describe the line sweep algorithm. From this first position, you have position of minimum, its jumps, and the maximum, in and max. Now, if we jump to the minimum, we mark this as event of increasing, last one, and we mark it as decreasing after the max, so -1 here. And then we can do just line sweep, move this line on events and calculate some Iranian sum, and this sum would naturally give you the balance of your events. Are the interval positive, that means you inside some interval, and if it's negative or 0, it only can be 0. That means you out of any range, and the crucial step is to check if the current cell is actually 0. Do not mark on ones, for example. Let's look at the code. So we have this extra array events, and we have Ryan sum. The first is 1 because we add 0, and after this 0 we mark it as -1, interval closes, and then we do this Ryan sum plus event, and if this current string letter is 0 and we are in a reachable interval, meaning this Ryan sum is more than 0, then we mark next event of open the interval and closing the interval, and the final step is to check if we have a balance positive and the last position is actually reachable because have character 0. Now this is a forward forward marking pass, and the algorithm is line sweep. But we can solve it in a different way, the backward pass, backward, GP. So instead of looking forward, we are looking back. So imagine we are at 0, and we look back from some minimum and a maximum. Let's look at the code, actually. So this is a DP solution. We have DP array boolean that has the answer is this reachable, is this point is reachable, and then we iterating and have also running counter that counts balance, and we mark the current point as if it's counter positive and current letter is 0, and we're looking backwards to change the pointer. So if opening interval is reachable, we're incrementing, and if closing interval is reachable, was reachable, we're closing it. So it's not obvious how it works, because why you do this, so it's reachable but you're still closing it. So it's not very straightforward, but it works. Now let's look at some Golfit versions. This Kotlin one is the same forward pass in line sweep. So this events array, and we use them counter. We mark increasing and decreasing, opening and closing border, and this Rust solution is the DP because it looks backwards. So it takes the current balance and asks if the previous opening was reachable and if the previous closing was reachable. So it changes the balance of the current cell. I think that's it for today.